What is the volatile modifier in C#? The volatile modifier is used to indicate that a field might be modified by multiple threads which are executing at the same time. When you use the volatile modifier, the compiler and the runtime are instructed not to cache the value of this field and to always read directly from its location in memory, which ensures that any thread will read the most up-to-date value. So let's get to some code examples that demonstrate the use of the volatile modifier in C#. Let's take a look at my first code example. I have created a class which is called background service with several methods: start, stop, and do work. The do work method is the one that simulates doing work in a loop until this work is actually cancelled. And as you can see, we are going to use a flag, a boolean, which is called isRunning, and we use the volatile modifier. The idea is to use the isRunning boolean together with our cancellation token source to exit the do work method gracefully. And this simulates a multi-threaded application, which means that we want to make sure that the isRunning boolean always provides its latest value and it is not cached by our application. In essence, we're using the isRunning boolean flag to control the loop, and when the stop method is called potentially from another thread, such as the main application thread, the isRunning flag is set to false, and this loop right here is going to see the updated value and exit. And we use the cancellation token to demonstrate how you might gracefully handle task cancellation in real-world applications. So let's take a look at the main method and see how we can use this code. First, we create an instance of the background service class. Then we start the service by using the start method. And then we have the service actually running, and we wait for the user input. So if the user presses enter on their keyboard, this is actually going to stop the service. And we stop the service by calling the stop method, which actually contains the code to gracefully terminate our background task. So let's run the code and see how it works. Okay, we have the service running, and press enter to stop. So I'm going to press enter on my keyboard, and we see a few more messages. Background service is running. We're waiting to gracefully exit the code. And then we have the service stop message, which indicates that our service has stopped running. Okay, now let's run a little experiment. Let's remove the volatile modifier and see if there is any difference. So I'm just going to remove the volatile modifier. Let's run the application and see what is going to happen now. Again, we need to press enter to stop the service. So if I press enter, we see the stopping service message. A few more background service is running messages. In this case, it's only one. Then we see the background service is stopping and service stopped. So there's actually no difference. You can completely skip the volatile modifier and think that your application is going to be running just fine. Well, this is not always the case. And now I'm going to try to explain why you need to use the volatile modifier in your C# applications. Okay, so let's discuss this briefly. How come in some cases using the volatile modifier makes no difference? Well, in short-lived or simple applications, such as this console application, you might not see any difference between using the volatile modifier or skipping it completely. Also, this could depend on your processor or the runtime environment, and some of these processors or runtime environments might use different type of memory caching, which means that also you might not see any difference between using the volatile keyword or skipping it. But in both cases, you cannot rely on that, which means that if you want to make sure that your application always uses the latest value of your variable, you need to use the volatile keyword. Okay, now let's quickly create a second code example. Let's assume that you want to code an application which periodically checks for changes in its configuration settings. This means that the configuration settings might be loaded from a file or remote service, and you want to make sure that your application uses the latest settings. And this is where we can actually use the volatile modifier to make sure that your application and all its threads access the latest configuration settings. So let's quickly do that. First, I'm going to create my configuration class. Okay, go add a new item, and I'm going to create my configuration class, and it's going to be public, and we can have several properties. For now, let's just do the public integer refresh interval. Let's say this is our refresh interval in milliseconds, and we're going to probably need a public string service endpoint. This could be our API endpoint, and you can add a few more properties, but for now let's leave it as is. Then I'm going to create my configuration manager class. So new item, let's do that. Configuration manager, and again this is going to be my public class configuration manager, and this is where I'm going to create my private volatile configuration variable. And let's go ahead and create our constructor, and inside we're going to create a new configuration, and we can do refresh interval equals 600, and we can do service in endpoint is our API endpoint, HTTPS API example.com API, and so on. And then we can actually create a background thread which refreshes our configuration. So I'm just going to add some of the code equals new thread, and I don't have to code this, but let's say we have a method which is called refresh configuration, and our thread sleeps for a second or so on, and it refreshes the configuration for us, and then we're going to have our configuration get current configuration method, which simply get current configuration, which simply returns our configuration. And we can just add, this is going to be our refresh configuration method, the implementation, which I don't have to really code, but now since we are using the volatile modifier for our configuration, every single thread which calls the get current configuration method is going to get the latest configuration, which means that even if your compiler or your CPU tries to cache the configuration object, all the threads which call the get configuration are going to get the latest configuration, and this is going to make sure that your application uses the latest configuration settings and works as expected. Okay, if I have to summarize why or when you might want to use the volatile modifier, this normally happens when you want to make sure that several threads in your application access the latest value of your variable. This is when you're not using lock and locking, which means that all the threads can access the variable, and you want to make sure that when they read that variable, they get access to the latest value. And you want to use the volatile modifier when you use simple flags, or when you have single writers and multiple readers, or also when you use reference types updates, which means that for the reference types where the reference itself might be updated and needs to be immediately visible across several threads, you might want to use the volatile modifier as well. And this is all for me for today regarding the volatile keyword in C#. Thank you for watching. Hit the like button and subscribe to my channel.